Okay, today we'll be talking about alkenes. There's two things we're going to touch on today. One is that alkenes can't rotate, and the other are that there are cis and trans isomers of alkenes. When I say that alkenes can't rotate, what do I mean? Well, first we have to define what an alkene is. An alkene is where there's a double bond between two carbon molecules. So it looks something like this. If I have carbon here and a carbon here, that would be an alkene. Okay, so gonna erase that. Um, if we have a long chain of carbon molecules, so drawing this out, say for example we have an alkene in here. So let's make the double bond right here. This double bond can't rotate. Single bonds in this can't. So the reason being is this. Alkenes kind of act, I kind of think of this as like a fence post. So if you have one fence post, or just one rod of wood, let's change colors on that. One rod of wood, and then you put another rod in between kind of these two rods of wood, I should say, is what we start out with. Then you put another rod in between. Well, if I wanted to rotate these pieces of wood, I can't, right? Because there's one point in there's one point of contact. So that rod rotates around, the other rod can rotate around too. Now, if I put in, say for example, I did two rods, and I did two rods in between these rods. Well, you can't rotate these. You can't do it. Well, at some point when you're rotating them, they're going to get crossed, and it's not going to allow you to rotate anymore. This is also true with something called alkynes. If you have three rods of wood in between these two rods, you wouldn't be able to rotate it very well. So these end posts here represent two different atoms, and the in-between rod represents a bond. And so it's a lot easier to rotate around one bond than it is to rotate around two or around three. Same is true for these bonds up here. If I'm looking at this bond can easily rotate because it's a single bond. However, this double bond cannot rotate because there's 2 points of contact in between those two atoms of carbon. So that's the first thing we really need to know. Second thing is we're going to talk about cis and trans isomers. So cis means same and trans means opposite. Cis and trans isomers are stereoisomers. What does that mean? Stereoisomers differentiate in their spatial arrangement, not in the connectivity of the actual atoms. So let's look at an example here. If I have a molecule like this, I'll draw a cis molecule. Well, in a cis molecule, the spatial arrangement is such that the functional group, or things that aren't hydrogen, are on the same side. So let's see here. Cis, let's do Cl and Cl. Whereas trans has a functional group on opposite sides. So we're going to go here, Cl, H, Cl, H. So the difference between these two is pretty obvious, right? Let's look at here the chlorine here. The chlorines are on the same side in this situation, but on opposite sides in this situation. So these, the other thing about this too is that we can't really rotate around this bond. It's extremely difficult to do. I hope this helps. Again, just to review, alkenes can't rotate, or it's very, very difficult for them to rotate. And so they won't in most circumstances. Cis and trans isomers are where the functional group is on the same side for cis. So I think cis and same kind of have that same sound. Cis, same, the same starting sound there. And then trans is opposite. So trans is opposite. Hope this helps.